In this video, we'll see one important application of capacitor. When a capacitor, a horizontal parallel plate capacitor, is kept in a liquid surface, it is lowered in a liquid surface, and how we place it is lower plate is just submerged in the liquid of dielectric constant K. So then what happens is that liquid, because due to the force acting on the dielectric material, the liquid rises to some extent, some height, and after rising to some height, what happens there? Equilibrium position will be obtained, because the weight of the liquid acts downward, and the force due to this the charge density on the plates of the capacitor acts in upward. That net force we'll see here. And what is the net force acting, what is the net electric field, due to that how much force is acting, and up to what height the liquid rises between the plates of the capacitor, that we'll see now. So here it is parallel plate capacitor to this a charge density minus sigma, and here for this plus sigma is given, and this is this plate, the bottom plate is lowered in a liquid of dielectric constant K. Say for example, the liquid level initially we can take like this. So due to this charge density, due to electric field between the plates of the capacitor, say the liquid level is raised to this height, and after that a equilibrium condition, equilibrium position is achieved. The equilibrium position, generally when weight of the liquid is balanced with the force due to electric field force, the weight of the liquid acts vertically downward. Okay, so here in this case, say this is negatively charged plate. By induction, this end, this surface, liquid surface, gets positive charge. So at this point P, what is the electric field due to this plate, due to the total capacitor, plates of the capacitor, due to negatively charged plate, this is sigma by 2 epsilon naught, acts vertically downward, and due to positively charged plate also acts sigma by 2 epsilon naught. So total electric field due to plates, charged plates, we can write as sigma by epsilon naught. So at point P, the total net electric field we can write as sigma by epsilon naught. And here the induced charge is there. So the induced charge density we can write as sigma I. Due to that at point P, the electric field acting is in upward direction. So I write induced electric field, and it is sigma I by 2 epsilon naught. So what is the net electric field at point P? If you write the net electric field at E bar at point P, so E is equal to, and here the charge is there, charge is present on the liquid surface. So what is that charge also will write. Okay, the charge here, if the area of the plate is A, and of course this liquid charge, that surface area also we can consider as A. So in that case, what is the Q, what is the charge there, charge induced, sigma I into A we can write, because sigma is Q by A. So therefore what is the force on that surface, on the surface of the liquid due to this electric field is simply it is EQ. Let us substitute what is E, sigma. This is the force acting on liquid surface. Due to that it acts in upward direction. So due to that liquid will be raised to a height h. So this height we can take as h. So at equilibrium we can write at equilibrium the force acting on liquid is equal to its weight, m into g, mass into g. What is mass also will calculate. So if the density of the liquid, say given as, say if the density of the liquid given as rho, so rho is equal to, we can write mass by volume. The what is the area? A is the area, and it raises to height h. Therefore what is the mass? Rho into ah. Therefore the weight at equilibrium, the force is equal to its weight. The mass is rho a into h into g. We can take, we can substitute equation 1 and 2. Okay, so one more point also we'll discuss. What is the induced um, charge density. That point also we'll see, because when dielectric is placed in between the plates of the capacitor, the induced charge density sigma I we can write as sigma into 1 minus 1 by k. So the F is equal to, I'm substituting this equation 3 in 1, and it is sigma by epsilon naught minus sigma I. So what is the what is the force due to electric field? The F is equal to sigma by epsilon naught. Let us use this bracket, sigma by epsilon naught minus, instead of sigma I, let us substitute sigma into 1 minus 1 by k there. So after substituting equation 3 in 1, this we obtain. Further, if you do little more calculation, substituting this sigma, equation 4, now we'll equate this equation 4 with 2. Simplification, okay, take it as homework. You can do the simplification. Finally, the equation for H we can write as k square rho g. Okay, so this is the concept. If you have any doubts, write in comment section. We will see another problem in next video.